Hello everyone, myself Preeti Kiran, PGT Chemistry from Kendriya Vidyalaya Number 1 Air Force Station Hindon. Dear children, I am dealing with P block elements, Unit 7 of Class 12 Chemistry. In the previous videos, we have discussed about the atomic properties, physical and the chemical properties and the important compounds of group 15, 16 and 17. This is the last part. This is the last video, and in this we are discussing with the 18th group, that is noble gases. So let's start. In this video, I am dealing with 18th group, that is the noble gases: helium, neon, argon, krypton, xenon, and radon. Here, the atomic numbers of the noble gases, which have already discussed in the previous videos. The atomic number of helium is 2, atomic number of neon is 10, then argon it's 18, krypton it's 36, and xenon it is 54. In the picture here you can see the ampules which are filled with the noble gases. In this slide, you can see that all the noble gases are marked in pink, and pink stands for the non-metals. And the name also suggests noble gases. So they are all gases, they are non-metals. Group 18 elements were discovered by the scientists near the end of the 19th century, and because they were so unreactive, they were initially called the inert gases. Also called the noble gases because they rarely react with the other elements and form few compounds since they are already stable. Rare gases is used often to describe these elements as they are only rare in abundance relative to the other gases found in the atmosphere of Earth. The valential electronic configuration of 18 group elements is Ns2Np6, except helium, which is 1s2. Here on the screen you can see the electronic configuration of all the noble gases. Down the group as we are moving, there is a change in the principal quantum number. There are 8 electrons in the valence shell, but they are entering into the new shell. Also, you notice that as we moving down the group, there is filling of the d and f orbital electrons. And the filling, the absence of the d orbital or the presence of the d and f orbitals, it affects and impacts the properties of the elements. Atomic radii, here you can see that down the group, the atomic radii increases from top to bottom, just like in the other groups. We have discussed that why that takes place in class 11th also and in the first video of this unit. The noble gases, they exhibit the very high ionization enthalpy. Now, the reason behind that why they have very high ionization enthalpy is due to their stable electronic configuration. You know that they have 8 electrons in their valence shell and the complete octet is very stable. So if you try to remove an electron, you have to give high ionization enthalpy. Just see the values of the ionization enthalpies which are given in kilojoules per mole. They are very high, but as we are moving down in the group from helium to radon, there is a continuous decrease in the values of the ionization enthalpy. It is due to the increase in the atomic radii, and when the atomic radii increases, the valence electron moves far off from the Nucleus. Electron gain enthalpy. As discussed in video 1 of this unit, the electron gain enthalpy can either be endothermic or exothermic. For many elements, energy is released when the electron is added. But now let's see what happens in the case of the noble gases. Here on the screen, you can see the electron gain enthalpy values of group 16, 17, and 18. And you can clearly see that the values are negative for group 16 and 17. But for group 18, the values are positive. So the reason behind the positive values of electron gain enthalpy for the noble gases is again the stable electronic configuration. Their octet is complete and they don't have tendency to accept the electrons. Now, all the noble gases except radon, they occur in nature. Radon is obtained as a decay product of the radium. The general configuration is NS2NP6. They generally do not interact with most of the elements. Due to the stable configuration, they have high ionization enthalpy, as discussed earlier. They are monoatomic, colorless, sparingly soluble in water. They have low melting and boiling point. Because of only type of the interatomic interaction in these elements is the weak dispersion forces. I have highlighted this in the red ink because it is asked many a times in your board exams that why the melting and the boiling point of the noble gases is low. So your answer should be due to the presence of the weak dispersion forces. Helium has the lowest boiling point of 4.2 Kelvin, and it has an unusual property of diffusing through most commonly used gas materials like rubber, glass, or plastic. Dear children, it was initially believed that noble gases could not form compounds due to their full valence shell of electrons that rendered them very chemically stable and unreactive. And that is why they were named as inert gases. But later on, the inert gases name was removed or not very well in use, and the new name was given to them, the noble gases. Now let us discuss why the noble gases name was given to group 18 elements. It is due to the noble gas compound. This was discovered by Neil Bartlett in 1962. The compound led to the discovery of the first noble compound is the red colored solid O2PtF6. Neil Bartlett was working on this compound and then he observed that and he realized that the ionization enthalpy of the molecular oxygen and xenon is almost same. The values are there on your screen. The ionization enthalpy of xenon is 1170 kilojoules per mole and ionization enthalpy for oxygen is 1175 kilojoules per mole. And when he realized this, Neil Bartlett tried to make the similar compound of the xenon and he was successful. And he prepared the first ever compound of the noble gases, that is XCPtF6. And it was the red colored solid. So if ever you get the question which you get in your board exams that who prepared the first compound of the noble gas, then your answer is Neil Bartlett. And name the first compound of the xenon or the noble gases, it is XCPtF6. Here on the screen, you can see that the compounds of xenon, and just focus your attention here. The compounds of the xenon are with the fluorine and oxygen. There are so many compounds of the xenon in different oxidation states. Few of them we will study in your class 12 as per the NCERT syllabus. But the reason behind that why xenon is forming the compounds with fluorine and oxygen only, the reason is fluorine and oxygen are highly reactive electronegative elements. The compounds of the krypton are fewer, only krypton difluoride has been studied. The compounds of radon have not been isolated but only identified, that is RNF2, by the radio tracer technique. There is no true compound of argon, neon, or helium. Now, let's discuss about the xenon and its fluorides. Xenon form the three fluorides when under three specific conditions: xenon difluoride, xenon tetrafluoride, and xenon hexafluoride. You just learn the balanced chemical equations and just see on the arrow every time the conditions are being changed, and the ratio between the xenon and the fluorine is also changed. When xenon and fluorine in the ratio of 2 is to 1 is taken, temperature is maintained at 700 Kelvin unsealed vessel, you get XeF2. To prepare XeF4, xenon tetrafluoride, take xenon and 2 moles of F2 in the ratio of 1 is to 5, temperature 700 Kelvin and 6 atmosphere pressure, xenon tetrafluoride is formed. To prepare xenon hexafluoride, xenon and 3 moles of fluorines are taken in the ratio of 1 is to 20, temperature 500 to 600 Kelvin and the pressure 50 to 60 atmospheres. There is another method of preparing xenon hexafluoride is from xenon tetrafluoride. Xenon fluorides, they are powerful fluorinating agents and they are readily hydrolyzed by the water. Xenon fluorides, when readily hydrolyzed even by the traces of water. Here you can see xenon difluoride and 2 moles of water. You get xenon, hydrogen fluoride and oxygen. The xenon fluorides react with fluoride ion acceptors to form the cationic species and the fluoride ion donors to form the fluoroanions. Here are the two equations which are frequently asked in your board exams. Here, xenon difluoride reacts with PF5. PF5 is a fluoride ion acceptor. So xenon difluoride changes into XeF and PF5 changes into PF6. Similarly, XeF4 reacts with SbF5. Again, SbF5 is a fluoride ion acceptor. So it changes into cationic species. But in the reaction which is given at the bottom, XeF6 plus MF, where M can be alkali metal like sodium, potassium, rubidium or cesium. They are fluoride ion donors. So XeF6 changes into XeF7 and it changes into a fluoroanion. Now, as per the VSEPR theory, the structure of the xenon compounds. XeF2 xenon difluoride is linear. Here is the structure of the xenon difluoride. At the equatorial positions, you can see the 3 lone pair of electrons. Xenon tetrafluoride is square planar. Here, the B structure, this structure is xenon tetrafluoride, and on the xenon you can see the 2 lone pair of electrons. Xenon hexafluoride is distorted octahedral because of a presence of the lone pair on the xenon. Xenon oxyfluoride is square pyramidal. Again, here you have to pay attention that there is a double bond between xenon and oxygen. And again, there is a lone pair of electron on xenon. This is square pyramidal. Then xenon trioxide, it is pyramidal. And in between all the xenon and oxygen, there is double bond. And xenon is again having a lone pair of electron. These are very important questions. Let me tell you, dear children, that in your board exams, you get a skill based question where you are supposed to draw the structures of the different molecules. So the Zinnan compounds, the structures of the Zinnan compounds are frequently asked in the exams. Here, one more property of Zinnan trioxide. It is a colorless explosive and a pyramidal structure. And Zinnan oxyfluoride is a colorless volatile liquid and it has square pyramidal structure. We have discussed this in the previous slide. Now the hydrolysis of XeF4 and XeF6. Now you have to pay attention that whether they have mentioned that it is a partial hydrolysis or a complete hydrolysis. Depending upon the moles of the water, you get different products. Let us see how. The hydrolysis is shown as follows. This is the first reaction is of Zinnan tetrafluoride. When the 6 moles of Zinnan tetrafluoride reacts with the 12 moles of water, you get Zinnan and Zinnan trioxide and 24 moles of hydrogen fluoride plus oxygen. Partial hydrolysis of Zinnan hexafluoride. Now in the partial hydrolysis, you take 1 mole or the 2 moles of the water and you get Zinnan oxyfluorides. But when the complete hydrolysis is there and when Zinnan hexafluoride is treated with the 3 moles of water, you get XeO3 and 6HF. You have to learn all the 3 equations and depending upon the question which is asked in the board exam, you have to write the equation. Depending upon that whether it is the case of a partial hydrolysis or the complete hydrolysis. The uses. The uses of the helium, it is a non-inflammable and light gas. Hence, it is used in the filling balloons for the meteorological observations. This question has been asked in the board exams that what property of the helium makes suitable to fill the balloons for the meteorological observations. And your answer should be that it is non-inflammable and light gas. Helium is also used in the gas-cooled nuclear reactors. The liquid helium has a boiling point 4.2 Kelvin and it finds use as a cryogenic agent for carrying out various experiments at low temperatures. It is used to produce and sustain powerful superconducting magnets which form an essential part of NMR spectrometers and magnetic resonance imaging systems for the clinical diagnosis. It is used as a diluent for oxygen in the modern diving apparatus because of its very low solubility in the blood. This last use you have studied in chapter 2, that is solutions, where the scuba divers they use the oxygen cylinder which is diluted with helium. The uses of neon. Neon is used in the discharge tubes and the fluorescent bulbs for the advertisement display purposes. Neon bulbs are used in the botanical gardens and in the greenhouses. Argon is used mainly to provide an inert atmosphere in the high temperature, metallurgical processes like arc welding of the metals or the alloys, and for filling electric bulbs. It is also used in the laboratory for handling substances that are air sensitive. There is no significant use of xenon and krypton. They are used in the light bulbs designed for the special purposes. Now few questions. Why are noble gases least reactive or why they are considered inert? Because the answer is their noble gas configuration is Ns2np6. That is, they have the closed electronic configuration. Their octet is complete. They are in their most stable state. And you have to write also that their ionization enthalpy is very high and their electron gain enthalpy is positive. Next question is, who discovered the first noble gas compound? and write the formula of the first noble gas compound. Neil Bartlett, as discussed, and XCPTF6 is the first noble gas compound. What inspired Neil Bartlett for carrying out the reaction between Xe and PTF6? As I've told you in the previous slides, that the Neil Bartlett was preparing a compound, a red colored compound of the formula O2PTF6, and then he realized that the ionization enthalpy of the molecular oxygen and that of xenon is almost same. And then he tried to make this compound of xenon and he was successful. Does the hydrolysis of xenon hexafluoride lead to a redox reaction? Now, the answer is no. The product of the hydrolysis are xenon oxyfluoride and xenon XeO2F2, where the oxidation states of all the elements remain the same as it was in the reacting state. If it is a redox reaction, then there must be change in the oxidation state of the elements. So when for such type of reactions, dear students, write the reaction, find the oxidation state of each element, and if there is no change in the oxidation state before and after the reaction, then it is not a redox reaction. There are a few more questions for you to solve. These are all from the board exams. Why do noble gases have comparatively large atomic sizes? Why is helium used in the diving apparatus? How are XeO3 and XeOF4 prepared? Give the formula and describe the structure of the noble gas species, which is isostructural with ICl4 negative, IBr2 negative, and BrO3 negative. List the uses of neon and argon gases. Thank you. Dear children, just now we have discussed about the simple physical properties of the noble gases, the atomic properties of the noble gases, why they are known as inert gases or the rare gases, and why the name has been given as the noble gases. And then we studied about the discovery of the compounds of the noble gases, who discovered, and how it leads to the discovery of so many compounds of xenon and the krypton also. We studied about their uses of the helium, neon, etc. I hope the content is easy to understand and you will like the video and it will help you to prepare this unit. Thank you so much.